Hey guys, it's Mrs. Diaz. It's been a long time. I hope you're all doing well. Um, I want to actually go back and start reviewing some of these homework problems with you. I'm probably going to make one video per day, because we do have this Unit 5 test coming up, and I know our circumstances are crazy right now. I mean, literally the whole world is on shutdown, but I really appreciate your patience and your hard work, because we're really almost done with this school year. So let's take a look at homework 5.1.1, rational functions. Let's sing song, a very famous song together, okay? And let's start reviewing. So the song goes, vertical asymptotes found in the denominator. Horizontal asymptotes, bubble butts eats to see. X-intercepts are found in the numerator. And the holes are the ones that cancel out, and the rest is history. Alright, so I know we have 1, 2, 3, 4 here at the top, but I actually want to go to number 5 and number 6. So let's take a look at 5 and 6. Those are the ones I want to focus on. Actually, let's start with 5. Okay. So number 5. Well, first of all, x-intercepts are found in the numerator. So if we set the numerator equal to 0, we're going to get 3/2. So we have an x-intercept at 3/2. Y-intercept is when you substitute 0 for x. So when you substitute 0 for x, 2 times 0 is 0, minus 3 is -3, over 0 plus 4 is 3/4. And then vertical asymptotes found in the denominator. So x equals -4. Horizontal asymptotes, bubble butts eats to c. This one's going to be eats to c because the exponents are the same since they're both 1. Then we're going to divide the coefficients. 2 divided by 1 is y equals 2. Now there are no holes because nothing cancels from the numerator and the denominator. And now we have some components to graph our picture. So the first thing I'm going to do is graph -4. That's our vertical asymptote. And then 1 and 2 is our horizontal asymptote. We have 0, -3/4. That's the y-intercept. And 3/2, 0. So that's 1.5, 3/2, 0. Now notice how we have already these 2 points in almost like this little quadrant. You see these asymptotes serve as our boundaries. Okay. These are our boundary lines, and so our graph piece is going to be in between the boundary lines, the asymptotes. This is where we're going to approach the asymptotes, but never ever touch. And then we have the other component, the other part of the graph is probably going to be up here. So the other part of the graph is going to be up in this quadrant. They're going to be on alternate sides. And that's for number 5. Alright. Let's try number 7. Number 7, let's start off with x-intercepts. So x-intercepts are found in the numerator, but you guys notice there's no x-coordinate here. So in this case, there is no x-intercept. No x-intercept. And that's because there's no variable here. Now for y-intercept, remember, we're going to plug in 0 for x. So we got 4 over 0 minus 2 is -2. But -2 squared is 4. So 4 divided by 4 is 1. And we have a y-intercept at 0, 1. Vertical asymptotes found in the denominator. So it looks like x equals 2. It's that denominator piece. Horizontal asymptotes, bubble butts eats to c. It's definitely bigger on bottom, so this is going to be bobo, which means y equals 0. Again, there are no holes because nothing cancels. Alright, let's sketch it. So vertical asymptote is at 2. Horizontal asymptote is 0. Y equals 0. There is a y-intercept at 0, 1. There are no x-intercepts. No holes. And now we have the boundary lines here, meaning our graph, we're going to pretend that does not touch. Okay, that's not going to touch. But on this other side, it's also going to look something like this. Okay, the reason these two are going in the same direction, you guys notice how these arrows are going in the same direction, is because look at this denominator piece. It has a squared. Anytime it has a squared or any even number as an exponent, the arrows go in the same direction right at that asymptote. So since the asymptote was x equals 2 from that denominator, that means both sides of the asymptote are going to be going in the same direction. If you look at the example earlier, they're going in opposite directions, and that's because the denominator piece had an exponent of 1. So if you have an exponent of 1 or 3 or 5, anything that's odd, that's when the graph will go in opposite directions. Okay, I'm going to go ahead and pause there, and we'll try number 9. Alright, let's take a look at number 9. Let's get started on this problem. So for number 9, you're going to notice it's a little different than the other two because there's quadratics on the numerator and the denominator. So let's try to do number 9. It looks like 3x squared minus 14x minus 5 divided by 3x squared plus 8x minus 16. Before we begin, you want to see if you can factor the numerator and the denominator, because if we can factor and cancel something out, then that means we might have a hole. So I'm going to start off with 3x and x because that's how we're going to get the 3x squareds in the numerator and the denominator, that first piece. And the negative 5 could be like 5 and 1. Now you have to be careful on where you place 5 and 1 because 3x times 5, that's going to be 15, and I want it to be negative 15. Plus 1 gives us negative 14. So those are my factors there. Now for 16, we could do 4 and 4. 3 times 4 is 12. I want positive 12 and negative 4, right? Because 12 minus 4 is 8. There it is. So those are my factors. Does not look like we have any holes because nothing cancels. So let's do x-intercepts. X-intercepts are found in the numerator. So it looks like we have a negative 1/3, 0, and 5, 0. Because when you set them equal to 0, 3x plus 1 equals 0. Subtract 1, divide by 3. That's where we get x equals negative 1/3. And of course this one set equal to 0, x equals 5. Let's try the y-intercepts. Y-intercepts are going to be setting the x value to 0, so plug in 0. That's going to be 1 times negative 5, which is negative 5. 0 minus 4 is negative 4, and then times positive 4 is negative 16. So negative times a negative is actually going to turn into positive 5/16. Vertical asymptotes found in the denominator. So we have x equals positive 4/3 and x equals negative 4. Horizontal asymptotes, that's going to be equal because exponents are the same, so we're going to divide 3 divided by 3. So y equals 1. There are no holes because, again, nothing canceled out, unfortunately. So let's go ahead and sketch out a graph. I'm going to start off with the vertical asymptote, which is 4/3. So this is going to be 4/3. That's like 1 1/3. So this is at x equals 4/3. And then x equals -4. 1, 2, 3, 4, -4. Oof, you understand that's on there. X equals -4. We have a y-intercept at 1. Y equals 1. What else? We have the y-intercept at 0, 5/16. So that's like 5/16, so less than a half. Maybe right there. Oh, you know what? Sorry about that. Let me go back because this is 1, so let's put 5/16 right here. And -1/3, 0, maybe -1/3 here, and 5, 0. 1, 2, 3, 4, 5, 0 is right here. So it looks like we have something like that. Am I missing anything? Y equals 1, got the vertical asymptotes. I think that's good. Alright, brace yourselves because this particular problem, this is where it gets weird, like super weird. Notice how we have some points here. So it might come from down here and then go back down, or it might go straight up. To actually figure out what happens, let's plug in a point like 1 for x. So we have 3 times 1, which is 3 plus 1. 1 minus 5, 1 minus 5. 3 times 1 is 3 minus 4, 3 minus 4, and 1 plus 4 is 5. So let's try this. 3 plus 1, that's 4. 1 minus 5 is -4. 3 minus 4 is -1. And 1 plus 4 is 5. So this is going to be -16 over -5. So that's a positive 16/5, which is like 3 and something. So it's 1, 2, 3. It's going to be up here. So it is going to go actually like this. Oof. We're going to use Desmos also to check this one. Now, the rest of them, well, if at x equals 4/3, notice there is an exponent of 1 on both of these. That means they're going to go in opposite directions. So if this piece here is going up, the piece on the other side has to go down. If this piece is going down, then the other piece here has to go up. And it's going to look a little bit like this. Not going to be perfect, but we're going to stay within the boundaries. Now remember, in the middle though, it can in fact touch the asymptote and cross the asymptote. I know that's so weird, but it can do that, and that's what it's doing for this particular problem. Alright, I'm going to stop it right there. Feel free to use Desmos, and I'm going to use Desmos to check my work. But what we really want to take from this homework is that famous song for rational functions. So please practice. Keep practicing, and hopefully I'll see you guys soon. Bye.